we're asked to find the rate of change of temperature with respect to time. That's it. No T is given to us. So what are we asked to find? The rate of change of temperature at any point. We're not given a particular point in time that with respect to time. We're asked to find exactly. We're asked to find T prime. So this will be a function that will eventually give us the rate of change of temperature at any point where the function is differentiable. But this function is what type? Polynomial, and it will always be differentiable. It doesn't have a corner. No polynomial function has a corner. No polynomial function has a cusp. And no polynomial function has a vertical tangent. Good. So what would you tell me to write? Bring down the power, multiply by negative 0.1. Negative 2t plus, we differentiate this, a constant times a function, but when I differentiate t, what do I get? What is the slope of t? 1 times 1.2. And what is the rate of change of a constant? 98.6. What is the rate of change? How fast is a constant changing?
0.
Right. The derivative of a constant is always 0. Good. So this is the function that will give the rate of change of the temperature with respect to time at any point t. Part B. Find the temperature at time the temperature at time t equals 1.5 days. What am I asked to find? Good. We'll do that in a minute. Find the rate of change at 1.5 days. What will I have to do next? Yes, in other words, T prime of
1.5.
That's it. Let's put them in the graphing calculator together and just plug in 1.5 and copy 2 answers. So in y equals, I have to revisit this at the end of the class because what in the back of my mind, the graph kind of showed that it has a maximum at 1. And if it has a maximum at 1, then the rate of change should be 0. So I have to revisit. Maybe I put in something wrong. So it's still in the back of my mind. So I'll go back to it. So we have the first function, negative 0.1 t squared plus 1.2 t or x because we don't have t, and plus 98.6. And I'm also going to put in the second function, which is negative 0.2 t plus 1.2. Instead of just plugging in numbers, right? And I go to second and table, and what do I plug in? I plug in, that's it. And I get both answers at the same time. So the temperature after 1.5 days is 100.18. But the rate of change right at the immediate, yes, 0.9. So this is degrees Fahrenheit. And this is the rate of change right after 1.5 days. So 1.5 days means that right past noon on the second day, right? So what is the rate of change at that point? Degrees per day. So let's copy this. So this is 100.18 degrees Fahrenheit, and this is 0.9 degrees Fahrenheit per day. Now, do you understand why I put those 2 functions in? Only because I was lazy and I didn't want to plug it into different functions. But it's up to you. It's nothing wrong with just plugging it in. Any questions on how to apply differentiation rules for a sum and difference of functions, and for the power rule. Do you think we need to practice more of any of those? Should we look at another word problem?
Yeah.
Very good. Awesome. So let's choose. Let's go back. So I see median age of women at first marriage, view to the horizon, blood flow resistance, problem 90.
Can we do number 90?
90, blood flow resistance. Awesome. Good pick. Let's do that. So 90 on page 147. Let's read the problem. We are given S of R equals 1 over R to the fourth. I refuse to work with that. What will you change it into right away? Very good, awesome, perfect. Can be used to determine the resistance to blood flow, S of, so this is resistance. Perfect. Blood vessel that has a radius R. R radius in, is it? Yes, in millimeters. Good. Part A. Find the rate of change of resistance with respect to R, the radius of the blood vessel. What am I asked to find? One more time. Find the rate of change of resistance, meaning the function, right? We're not asked to plug in anything. And I can't plug in anything until I find the function anyway. So in part A, the rate of change of resistance with respect to the blood vessel's radius.
R prime.
S prime of R, good. How will you write it? What is it? Does it equal to?
It's negative 4
Times
R
to negative,
4.
we have to
5.
subtract, yes. So this will be negative 4 over R to the fifth if I need to eliminate the negative power. Part B, find the resistance, not the rate of change, the resistance at R equals 1.2. So part B, I'm asked when R is 1 point, one more time, but just make sure, yes, 1.2 millimeters. I'm asked to find the resistance when the blood vessel's diameter, not radius, I'm sorry, is 1.2. What am I asked to find?
Is that, where did you get the file from? The negative file from?
So the formula for the power, is this. Negative 4, negative 4, negative 5 minus 1. Good. So then what are we asked to find in part B?
S of 1.2.
Very good. Don't write it just yet. In a minute, let's look at C also. Find the rate of change of S with respect to R when R is 0.8. So, because I would like to put both in the calculator. Now I'm asked to find the rate of change of the resistance when the blood vessel has a radius of 0.8 millimeters. I'm asked to find
Your S prime
of 0.8. Very good. So let's put those in the graphing calculator. So in y equals, clear anything you have in there. And the first one is 1 over. I prefer to write it like this, but you can write it the way you like. And the second one, which is a negative 4, and x to the power of negative 5. It's just easier for me. It's up to you how you want to put it in. So then second and table. And I'm going to plug in both, but I'm going to just read what I need. I'm going to plug in 1.2 and read just one of them, and 0.8 and read the other. So for 1.2, I will read 0.48. For 0.8, I will read negative 12.21. And measurement unit. So 0.48. And they don't say how many decimal digits, so negative 12.21. And now we have to write the measurement unit. So the resistance was to blood flow. It doesn't, give us a measurement unit, so I'm going to say resistance to blood flow, okay? And the second one is
Resistance in millimeters
per millimeter.
per millimeter.
Yes, because it's the rate of change of resistance with respect to radius. So resistance per millimeter. How do we feel now? Is this better? Is this better before we move on? Yes? Yes, please, Brian.
And again, I just want to make this question. And so the general language they're using, best to just memorize that, right?
Yes, so we only have two rules so far. One of them is the power rule. X raised to a power prime, bring the power down and subtract one from the power. The second rule is when we add and subtract functions, and I want to differentiate the sum of two functions or a difference, I differentiate the first one by itself, plus or minus, differentiate the second one by itself. That's basically all we had so far. Now, I do have certain functions that I should remember how to differentiate. I would like the square root, for example. The square root prime is 1 over 2 the square root of x. I should remember that 1 over x prime is negative 1 over x squared. So let me write those for you. So I should remember by now this. And I should remember this. These should be, if at any point in time we want to prove this again, let me know. But these should be remembered moving forward. In 1.6, we have two more rules. Product and quotient rules of differentiation. So remember when we said a function plus another function prime is f prime plus g prime. And if it's a difference, it's a difference. We use this without even thinking, right? We used it on a previous problem, right here, on this one, right? It was a function plus another function originally, and we differentiated separately. They're not connected. Okay, now the product rule and the quotient rule are a totally different situation, totally different. Do not assume anything here. So if I have a function multiplied by another function, in other words, I want to and I need to differentiate a product, here is the rule. The first function prime times the second one, but plus the first times the second one prime. So here's how I think it's better and easier to remember it. Any first function times any second function prime will be the first function prime times the second plus the first times the second prime. This is how I recommend you remember it. So if we have a product, function 1 times function 2, and we need to differentiate a product, this is the rule we have to use. So let me give you an example right here before we look at the quotient, with an example with the quotient, and then we pick problems from your book, whatever you want. So let's say I have x to the third times the square root of x. There are several ways here, but I want to illustrate the product rule. This is not the only way. And this is, for this particular function, I would not particularly use the product rule. I will change this into 1/3, and I will add 3 to 1/3. Into 1/2, 3 to 1/2. So, but let's say these are two functions. Let's illustrate. Function 1, function 2. What is the function 1 prime? 3 x squared, right? I differentiate x cubed into 3x squared, correct? Multiplied by the second function untouched. So this was the first function and this was the second, right? The first function prime and the second one untouched. Plus, I copy, yes, of course. I copy x cubed, I looked here and I copied that. Multiplied by, and now I differentiate the second one. So this one gets copied and now this one gets differentiated. And I know that this is 1 over 2 the square root of x. And this is it. You don't have to do anything else. So one more time, this was the first function. I differentiated it. Then I copied it by the second function, and then plus. I copied the first function because that's what it says. And then I differentiated the second one, which is 1 over 2 the square root of x. Let's look at the quotient rule, and then we pick problems from your book. Again, the quotient rule, totally different. Do not assume anything, and you have to remember it as is. Yes, please. Right, go ahead.
How did you get from x cubed to 3x squared for the first?
Very good. Okay. X to the third prime is 3 times x to 3 minus 1. X to the third, 3 times x squared. Is that okay? Everyone? Yes? Okay, perfect. Again, do not assume anything. This is a ratio. The numerator will be this, but with minus. So f prime g minus f g prime. Same with the product, but minus. And the denominator has nothing to do with the derivative. It's just the g function in the denominator squared. Totally different rule. So if you want to remember it like this, the first function over the second function prime, first function times the second minus the first times the second prime, divided by the second squared. Let's illustrate and then pick problems from the book. I'm going to use the same thing. 3x cubed over the square root of x, everything prime. Exactly what we did before. I'm just going to copy what I did before with minus. 3x squared the square root of x minus x cubed 1 over 2 the square root of x. Everything we did a minute ago, identical steps, but minus. Now, what about the denominator? I have the denominator, which is the square root of x, and I have to square it. What do I have in the denominator? Good. Which is
X.
Perfect. Yes, I can further simplify, and I will. I can separate the two. I can separate this and simplify it on x. So 3x the square root of x minus x squared 1 over 2 the square root of x in order to have the simplified form. I separated the two fractions. This over this gives us this. This over this gives us this. And now feel free to choose anything you want. And the problems are on page 154. Page 154 from 1 through 48. We want to illustrate the product and the quotient rules. And then if we have time, oh, we only have 5 minutes left. No, I don't know how time flies in this class. Okay, so any preference? If not, I will choose 56. No, not yet. You want to start with a product?
Can we do 7?
7. Very good. Let's start with 7. We have in 7 y equals 3 the square root of x plus 2. multiplied by x squared. Will I ever use the product rule on this? No. I will distribute. I will distribute in here and combine like terms, or say this is x to 1/2 plus 2. But we want to illustrate the product rule. And you can say, okay, so if you want to use the product rule of this, when do you use the product rule? We need to practice this for the next section. The next section deals with the chain rule, in which we will have power 5 here and power 10 here. I'm not going to ever distribute. It will take me an hour to distribute. So that's why we need the product rule. So let's illustrate as is without simplification. Okay. So this is function 1. This is function 2. So then dy over dx, you can also write y prime. Both are acceptable. You can also write f prime of x. All these notations mean the same thing. Let's differentiate the first one. And remember, we know a formula for this. So we don't want to change it to x to 1/2 and reinvent the wheel. We know what the square root of x prime is. So it's 3 over 2, the square root of x. What is the derivative of 2? How fast is the constant changing?
0.
Perfect. Times the second function plus the first function, 3, the square root of x plus 2, times the second function prime, 2x. I don't need you to do anything else. This is it. So one more time, let's summarize what we did. The first function prime is this, times the second function, plus the first function times the second function prime.
Can you go over I prime with 0?
Say it again.
The first one prime?
Yes, this prime is 0. 3 is a constant, and I differentiate the square root of x, which we did last time, is 1 over 2 the square root of x.
Ah, gotcha.
Any questions on this?
So we did the 1 over 2 square root of x times the constant.
Times 3 over 1.
3 over which is okay.
Correct. Let's choose a quotient, because I only have a couple of minutes, so you have an example with a quotient. So please choose a quotient, a ratio. Can I choose one? I would like to choose 46. Same page. And that is 3x squared plus 2x at the top, and the denominator, x squared plus 1. So this is function 1. This is function 2. So f prime will be, I can start by writing the denominator immediately as x squared plus 1 squared. There is no derivative in the denominator of the quotient rule. The top prime, can anyone give us this function prime? Excellent. Plus? Very good. Times the bottom one. Minus the top times the bottom. Is this done? No. Do not please attempt to simplify this piece of a term with a factor in the denominator. Be very careful. I will have to distribute, combine like terms, and simplify as much as I can. So 6x times, or x squared times this, 6x cubed plus 2x squared plus 6x and plus 2 minus 6x cubed minus 4x squared. X squared plus 1 squared. These two go away. Negative 2x squared plus 6x plus 2 over x squared plus 1 squared. Yes, I can factor out a negative 2 and simplify a little bit, but there is not much else I can do. Any questions?